Hello everyone. On this video we will look at the conic section for an ellipse. Okay, and this is one of the two videos for this particular topic. Okay. So first we're going to look at the geometric property of an ellipse. An ellipse is really just like an oval shaped circle. I just hand drew these. You can Google a more perfect one, but I didn't want to sit back and take too much time trying to draw a perfect ellipse when really all we're doing is using this video as a way to explain where the formula came from and more of the concepts. Okay, so a geometric property of an ellipse is just a set of points on a plane where the sum of the distances to the foci, which are the focus points, that's the point here and here, those are the focus points, is a fixed constant. Okay, so if we pick any point on this ellipse, we could pick here, we could pick here, we could pick here, it doesn't matter where. The distance from that point, if we add them together, so from that point to this foci and this focus point, if we add them together, so this distance is d1, this distance is d2, it will equal a fixed constant. Okay, same thing here. If we instead of stopping here, if we stopped here and we decided to put our point there, the distance from this point to this focus point, and this is the focus, and this is the focus. Remember, just the plural focus is foci. So when you're talking about one, it's a focus. When you're talking about both, it's a foci. Okay, so if we add those distances together, we will have a fixed constant. All right. So if you are still writing this, feel free to press pause. But we're going to go ahead and move on to our next page. And this is where we're going to start to form our equation. Okay. So to form our equation, we're going to assume that the ellipse is centered at the origin, which is the point 0, 0 on an xy axis. So if we have an xy axis, it's centered right there. Okay, so the center will be somewhere around here, but we're not looking at the center right this moment. Okay, so that means the foci will be at negative c0 and c0. Any constant, you can put any value in there you want to. We just use c to represent a numerical value or point on the x-axis in this case. Okay, so the distance here, so negative c0, and this is the foci at point c0. And let's say the point where we stop on the actual ellipse, we'll say that's x comma y. All right. And once again, we know that the sum of these two distances is going to equal a fixed constant, but we're going to call that fixed constant 2a, where a is, of course, a numerical value. And this doesn't mean the fixed constant is always going to be even. Let's say if your fixed constant was 3. We don't know if it is, but we'll just pick a number 3. Then a will just equal 3 divided by 2, where the 2's would cancel and it will be 3. So this fixed constant can really represent any numerical value. All right. Okay, so the first thing we're going to do is we're going to find out just how long these distances are. How do we do that? We're going to apply the distance formula. And that is the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so that's our distance formula. Okay, so that means our distance 1 plus distance 2 is equal to 2a will become, remember our distance 1, we have x2 minus x1, so we have x minus negative c, so that will be x plus c. So that would be the square root of x plus c squared plus You have y2 minus y1, so that's y minus 0, so that's y squared. So y minus 0 squared is just y squared. Plus, our distance 2, our x2 minus x1 is x minus c. Oh, forgot to put my square root. Squared plus y2 minus y1 is y minus 0 squared, or just y squared, is equal to 2a. All right, so what do we do here? Well, we have to get rid of those square roots. Let me kind of get this plus sign and move it over a little. There we go. So we isolate our square roots and remove the symbols by squaring. Isolate a root and square. All right, so let's say we isolate this one. We can pick either one, but we're going to isolate this one, which means we have to subtract this from both sides. So we subtract the square root of x minus c squared plus y squared on both sides. And if we do that, we should get the square root of x plus c squared plus y squared equals 2a minus the square root of x minus c squared plus y squared. All right, and now we square both sides. So we square this side and we square that side. Okay, so we know that the square root and the square cancel each other out. So this just becomes your radicand, which is x plus c squared plus y squared equals, and if you get 2 minus the square root of x minus c squared plus y squared, and you square it, and you use the FOIL method, you will end up with 4a squared. That's your first. Then your outer is minus 2a times this and minus 2a times this. So you end up with minus 4a times the square root of x minus c squared plus y squared. And then your last will be just this term multiplied to itself. So you'll end up with positive, and the square roots will cancel each other out. So you end up with plus x minus c squared plus y squared. All right, so now what we're going to do is we're going to expand. We're going to get rid of those x plus c and x minus c squares. Okay, so x plus c times x plus c is going to give us x squared plus 2cx plus c squared. Okay, that's just an expanded version of this one, plus y squared equals 4a squared minus 4a times the square root of x minus c squared plus y squared plus, now we expand this one, x squared minus 2cx plus c squared plus y squared. Ooh, almost ran out of room there. Okay, so now we start to notice some things can cancel out. If we subtract x squared from both sides, these two will cancel out. If we subtract c squared from both sides, these two will cancel out. If we subtract y squared from both sides, those two will cancel out. All right. Now, if we add 2cx to both sides, so if we add it here and add it here, we end up with 4cx minus, subtract 4a squared from both sides, 4a squared equals negative 4a times the square root of x minus c squared plus y squared. Okay. Now, if we divide each one of those terms by negative 4, we end up with negative 4 divided by negative 4 is positive a squared, so we'll put that first. Divide this by -4, that becomes minus cx equals, divide that by -4, becomes a times the square root of x minus c squared plus y squared. Okay, now what we're going to do is we're going to square both sides because we want to get rid of that square root. Can't do anything with it. Square both sides. All right. Well, we're kind of running out of room, so we're going to continue this on the next page, but we're going to square both sides. All right, so we're going to pick that up on the next page. If you're still writing, of course, feel free to press pause, but we're going to go ahead and move on to the next page. All right, so if we square both sides, of course, we have a squared minus cx squared equals a squared times x minus c squared plus y squared. Okay, so remember here, the a was on the outside of the square root, so that's why that was squared separately. Then the square root and the square cancel each other out, so that's why we have just the radicand here. So if we expand this, a squared minus cx times a squared minus cx, we will get a squared minus 2a squared cx plus c squared x squared equals a squared x squared minus 2a squared cx. Of course, we're expanding this one, plus a squared c squared plus a squared y squared. All right, so all we did here, we expanded this one, x minus c times x minus c. Then we distributed the a squared to all of those terms. All right. So if you notice here now, we have, if we add 2a squared cx to both sides, those two cancel out. All right. So on this side, we have a plus c squared x squared. But we're going to move this over to that side, and we're going to bring this a squared c squared over to this side. So if we subtract a squared c squared, so a squared minus a squared c squared, then we subtract that on both sides, that will equal a squared x squared minus c squared x squared plus a squared y squared, because we still have that term there. All right, now quick side note before we continue. Since d1 plus distance 2 is equal to 2a, we're going to let 2a be greater than 2c, which means that a will be greater than c. So we know that a squared minus c squared is positive. Okay, so if a is bigger than c, so let's say if you have a is equal to 8 and c is equal to 5, a squared minus c squared will be a positive number. So that means we'll let a squared minus c squared equal b squared, because no, b squared will always be positive. Okay, remember, we're dealing in just real numbers. Okay, so the only way b squared will be negative is if we use complex numbers, which we are not. All right, so kind of separate that a little bit. All right, so we're going to go from here and jump right down to there. So we're going to factor out the a squared. So you have a squared times a squared minus c squared. Oh, this should be a to the 4th. Sorry about that. I just noticed that. This should actually be a to the 4th. Okay, because when you get a squared, it will give you a to the fourth. Sorry about that. Okay, so now if we factor out the a squared, we get a squared minus c squared equals x squared times a squared minus c squared plus a squared y squared. All right. So how do we have our a squared minus c squared? Well, remember, a squared minus c squared is equal to b squared. We have a squared b squared equals x squared times b squared. Oh, move that up a little bit. There we go. Plus a squared y squared. All right, so I'm just going to move this, kind of switch sides. So instead of a squared being on the left, I'm going to move it on the right. So I'm just going to flip it. So we have b squared x squared plus a squared y squared equals a squared b squared. Okay, so we know that if we divide each term by a squared b squared, we will end up with b squared x squared over a squared b squared plus a squared y squared over a squared b squared equals a squared b squared over a squared b squared. Okay, so on this term, the two b squares will cancel out. On this one, the two a squares will cancel out. And these are exactly the same, and anything divided by itself is just 1. So that will give us x squared over a squared plus y squared over b squared equals 1. And that is the standard form of the ellipse. Centered at the origin. All right, now you don't have to go through all of that to answer any questions. This is just how the formula came to be. All right, so if you are still writing, of course, feel free to press pause. We're going to go ahead and move on to the next page. Okay, and this will just kind of explain what happens if we kind of make little tweaks to the formula. Okay, so we know that x squared over a squared plus y squared over b squared equals 1 describes an ellipse centered at the origin and is elongated horizontally, which means it will look, of course, like that, with the foci at the points C0 and negative C0. All right, so this question, what if the ellipse is elongated vertically, which means what if it looks like that? Well, the proof is pretty similar, and I'm not going to go through the entire proof again for just to end up with the same answer. But if the ellipse is centered at the origin and the foci are at 0C and 0 negative C, remember your y values are now changed. Here was the x values. Here your foci are on the y axis. Then the ellipse is elongated vertically, and the equation is x squared over b squared plus y squared over a squared equals 1, where a is greater than b, and a squared minus b squared is equal to c squared. All right, so I want you to notice the difference between the two. For both of them, a will be greater than b. But if you notice, the a squared is under the x-axis when it's elongated horizontally. The a squared is under the, not x-axis, but under the x term when it's elongated horizontally. Notice the a squared is under the y term when it's elongated vertically. Okay? So when you look at your equation, you will know which direction it's elongated either horizontally or vertically, based on which term has the larger denominator, or a value or b value. Okay, whichever one has the larger a value, the larger a value is underneath the y, it's elongated vertically. The larger a value is underneath the x, it's elongated horizontally. Okay, so that's one thing you want to look out for. Okay, now what if the ellipse is not centered at the origin? Well, if it's not centered at the origin, you just replace the x with the x minus h to shift the graph h units horizontally. And you replace the k with y minus k to shift the graph k units vertically. Okay, so the h value shifts it left to right, the k value shifts it up and down. All right. Okay, and I know this is a lot to write, so if you're still writing, feel free to press pause, but we're going to go ahead and move on to the next page. Okay, so a few other little side notes. You have the line segment that extends from one extreme point to another, and it passes through the center and the foci. That's called your major axis. The two ends of the major axis are the vertices. Okay, so these here will be your major axis because this is your center, and this is one end of your major axis, and these are the other ends of your major axis. All right, so this is your vertex, and this is your vertex. This is your vertex, and this is your vertex. All right. Now, your minor axis goes through the center and is perpendicular to the major axis. Okay, so your minor axis would go along the shorter side. Okay, so it's perpendicular to your major axis. So from here to here is your major axis. Uh-oh, move that up some. And from here to here is your major axis. Now the short one is your minor axis. And these are your co-vertices. So from here to here is your minor axis. And again, the vertices there are called your co-vertices. All right, so this is elongated. Oh, move this over a little bit. There we go. Elongated vertically and horizontally. All right, so if you're still writing this, of course, feel free to press pause to catch up. But we're going to go ahead and move on to our last page, which kind of brings everything together. All right, so once again, remember that this is elongated vertically, this is elongated horizontally. Okay, this is your major axis, and this is your major axis. So at the ends of your major axis is your vertex. Okay, now remember, this is your minor axis, and this is your minor axis. Okay, now remember your foci, or your vertex, goes through your foci. Okay, so that's a focus, and that's a focus, and of course, when you're talking to each of them, they would be foci. All right, so your foci goes from 0C, and this is C0. And this is your center. And your center, I'll just put CTR, is H. K. Okay, that's the point HK. Now, I'm going to expand this. Now, the distance from the center to your vertices is A. And the distance from your center to your co-vertices is B. All right, give you a second to finish drawing. All right. So now we're going to look at the elongated horizontally. And once again, this is your major axis. Oops. Where this is your vertex and this is your vertex. Now the distance from your vertex to your center, remember this is again your center, which is HK, and the distance from your center to your vertex is a value that we will call A. Okay. So right now what we're going to do, we're going to put our focus points. Remember that's negative C0 and C0 because that's on the x-axis. Okay, so we're going to look at all the little formulas that you will need. Okay, so if you're looking for your domain, that will equal H minus B, H plus B. And your range will equal K minus A, K plus A. Now your major axis, oops, clean that up. Will equal 2A. Because remember, your major axis is from the vertex to the center, and the vertex to the center, that's A plus A, so you have 2A. All right, now your minor axis is 2B. Okay. Now we already know that your center is HK. But now we're going to look at how to find your foci when you're actually just given a few details. So if you're looking for your foci, that's H plus or minus C, K. So wherever your center is, if you know your C value, you just add and subtract, and that will be your foci. Because remember, C squared is equal to A squared minus B squared. So if you know your A value and your B value, you can find your C value. Okay, and we also know that A will be greater than B. Okay, now if you were looking for your vertices, that's going to be H, K minus A. Let me clean that up a little bit. K minus A and H, K plus A. Remember, your center is HK, so your vertices, HK plus A and K minus A. So plus A and minus A. All right, so if you have a standard ellipse, that would be x minus h squared over a squared plus y minus k squared over b squared equals 1. Of course, where a is greater than b. All right, now we're going to look at the domain when it's elongated horizontally. Your domain is going to be h minus a, h plus a. Okay, because remember your domain is your x-axis. Move that over. So h minus a, h plus a, so that's your domain. Your range is going to equal k minus b, k plus b. Your major axis is going to equal 2a. Your minor axis is going to equal 2b. Okay, your center, just like before, is going to equal hk. Your foci are going to equal h and k plus or minus c. Okay, and of course that's where c squared is equal to a squared minus b squared, and a is greater than b. Okay, your vertices going to equal h minus a, k, and h plus a, k. Okay, which means for your standard ellipse formula, you have x minus h squared over b squared plus y minus k squared over a squared equals 1. Okay. Oh, forgot one thing. Your co-vertices. Okay, your co-vertices. Let me scroll down. So hold on one second. I'm just going to scroll up a little bit. When it's elongated horizontally, your co-vertices are h. I'll write that at the bottom here. H, k plus b, h, k minus b. Because you're starting at the center, h, k plus b, k minus b. And when it's elongated, give me a second, I'll move my hand. Elongated vertically, that means your co-vertice will equal, I'm just going to scroll up here just for a second, h plus b, h minus b, and your y value will be k. H plus b, k, h minus b, k. All right, so I'm just going to move this up so you can get all of those little details. So all of those formulas should tell you everything you need to know and solve most of the problems that you will have concerning an ellipse. All right. So, of course, if you're still writing, please press pause and finish up. But that is it for this video. Hopefully it made sense, and I'll see you on part 2 of this video where we'll go over some examples.